So today another coding practice. So in this video, I will solve the question, remove nth node from end of list. So in this question, I'm giving the head of the linked list, remove nth node from the end of the list and return its head. Okay. So the question is quite simple. I'm given the linked list and I will remove the nth node from the end of the list. Yep. So the input should be head, which is the node object, and also n, which is an integer. And yep, that's it. And I will return the head. So probably this is the original node, but only if the case when n is equal to the number of the nodes, it should be the second head. Okay. So let me think of this with some example. So, oh, by the way, I'd like to confirm something first. So what I'm wondering is if head is null or not. So from this constraint, I can find that no, the size is from 1 to 30, so there is at least one node. Okay. And for n, I'm just wondering if it can be, invalid integer. Like, say I have 5 nodes, but n is 6 or something. Yeah. So, but it cannot happen from this constraint because n is smaller than the size. Okay. So I can confidently say I can find the removed node in the linked list. Okay. So let's think. Let's think of this question with some example. Say like this. So in this case, the node I'd like to remove is the third last node. Third node from the tail. So this one, 22. So my task is to return the node 00, but connected to 11 and then 33 to 44. Okay. So I think the approach I can take for this question is that firstly, count the number of nodes. In this case, this is 0 through 5. Then I will find, I will calculate how many, which index is it from the head. So I can calculate it from, in this case, there are 5 nodes, and I'm looking for the third node from the last, which is equal to the 0, 1, 2. So third from the head. Hmm? No, what do you mean? And in this way. Okay. Yep. So let me quickly confirm this. If n is 1, which means the last node, the wait. I see. So if I is 0 indexed, I just have to do this. Yeah. Okay. Okay. So this is what I should do. Okay. Then remove the iced node, and then I will return the head. And as I said, when I is 0, I have to remove the head, and I have to return the second node. I have to take care of that. Okay, so I will start the implementation this way. So I will implement some method later. So okay, so this is it. So now I will implement the count nodes method and remove ice node. Okay, so okay, so I can count it in this way. Hmm. So in this way, now I can point to the ice node. Yep. So I will remove that node. Wait, but because I have to remove this node, I have to know I mean, if I were to remove the node, I have to know the node previous, which is previous. Sorry, if I'd like to remove the node, I have to know the previous node because I have to change the pointer from that node. Okay, so in this way. Hmm. So right here, I update the current dot next so that I can skip the ice node. Okay, this is it. So yep, a small approach I can take is here I use the pseudo head. Yep. Okay, let me implement in that way. Oh no, yeah, sorry, it's fine. Okay. Okay, now I will implement this. Sorry, I will walk through my code. So let me think of this case, and I try to remove n is 2. In this case, I'd like to remove this one. Okay, so now in line 27, I count nodes. And yep, I omit this, checking this count head nodes method. Yep, because I'm pretty sure on this. So I assume that this is now 3 minus 2 is 1. Okay. Then, because I from head is not 0, I go to line 34 and I try to remove node index 1. Yeah. And here in line 46, ice is 1. So this is true. Okay, in line 49, now current is pointing to head. Yep. Then current nth is 0. And because current nth is smaller than ice minus 1, which is 0, so 0 is smaller than 0. This is not true anymore. So I go to line 56, and current.next is now pointing to current.next.next, which is 3. Now 1 is pointing to 3. And head is returned. 1 is returned. Okay, good. I'm pretty confident, so I run my code. Good, I submit my code. Okay. So I have another approach in my mind. So I will implement that. So if I'd like to remove the third node, I'd like to remove this. And I'd like to reach this node somehow to remove this node. However, let's say if I'd like to remove the second node from the head, I can easily find that node just by traversing from head. So I will reach the first head, the first node, which is 2 minus 1. Then I update the pointer of the first node, next pointer of the first node to the third node. That's what I will do. But in this case, I'd like to know second to the last, second node from the last, so it doesn't work in that way. However, there is a way to find this second to last node easily. It works in this way. So I will use 2 pointers. And fast pointer and slow pointer. And fast pointer, firstly, moves by 2. Yeah. Oh, this example is actually not good. Let me just think with ns2. So in that case, I'd like to remove this one. And what I can do is move the first pointer by n step, which is in this case 2 steps. Then I move fast pointer and slow pointer at the same start speed until fast one reaches the end node. So first it goes like this, then it goes like this. So now I find that slow is 1 point before the second last node. Second node from the last. So now I update the pointer of throw, next pointer of throw to next.next. Okay, so that's what I can do in this question. So let me outline the code. it goes in this way. Okay, so one edge case I have to think is if n is exactly the ranks of the, um, list, in that case, first pointer actually cannot move 5 steps. Yeah. So in that case, I just have to return head.next first. I can already return it. Okay. Now I will implement this. Wait, how can I know? Oh, wait. In line 14, I cannot know this actually. So I can know if n is equal to length of the list if first pointer cannot move, is trying to move beyond the length of the linked list. That's why I have to take care. Okay. Yeah. So this is what I will do. And if pointer moves beyond list, this returns none. Okay. So let me do it in this way. No, let me return false. Okay. So, yep, in this way, I handle the edge case. Then I will do line 10. Yeah, I move the 2 pointers in this way. And then in line 11, I remove throw.next. Okay. Then I return head. Okay, so this is it. Now I will implement move pointer. Hmm? Ah, okay. Okay, but I have to take care. Oh, never written true. But I have to take care if p.next is none, I will return false. Okay. Good. Now let me check my code. So firstly, I will try with this, and n is 2. No, actually I will try with this. Okay, in this case, first is now head, and throw is also this. And now in line 26, I try to move pointers by 1, first pointer by 1. So in line 31, this step is now 1. So I do the iteration for 1 step. And now p dot next is, because none, this returns false. So in line 26, reach this false. So in line 27, this is evaluated as true. So I return head dot next, which is none. Okay, good. Yep. So I will try one more case. So let's try to remove this. And it's 1, and the linked list is like this. In this case, in line 27, I move the pointer by 1 step. So in line 42, the iteration step is only 1, and p dot next, which is fast dot next, is not a none. So I move this. Yep. Then I return true. Okay. Now reach this true, and in line 28, this is yeah, sorry. Not this is not reach this false. I go to line 32. So first dot next is until first dot next is none. Yes, this is true. So I move first pointer and also throw pointer. Then in this case, it's the end because now first dot next is none. So in line 36, throw dot next is throw dot next dot next, which is none. So now 1 is pointing to none. So and I return node 1. Okay, good. I execute my code because I'm pretty confident on my code now. Oh, throw is now none. So why is it? So in this case, let me try it. I'd like to remove this node. And first node and throw node is node 1. And I move the fast node by 2. Then I move fast node and throw node in the same speed. First read this and then read this. And at this moment, fast dot next is none. So I go to line 40 and throw dot next is throw dot next dot net. I think this is pretty good. Why this fails? Mm. Now throw is at node 5. Both of them are at node 5. Seems like the fast pointer is not moved in the move pointer method. I don't know. Wait, why is it? Yeah, so in line 36, fast and slow is both of them are node 1. So it seems like move pointer was not working. Hmm? Wait, sorry, I'm writing something quite weird. So P is just a pointer. So in line 53, I'm just changing the node which is pointed by just a variable P. Yeah, and this is not propagated. I mean, this doesn't affect the fast variable in line 28. So it doesn't work. So obviously what I should do is return the pointer. Yep, in this way. Okay. Okay, so I think it works in this way. Good. So I submit my code. Great. Okay. Oh, sorry. So I will do the complex analysis. So for time complexity, this would take O of n, and space complexity, this is the constant space, obviously, because in this method, I move the first pointer and the throw pointer, and both of them just goes from the first head node until the tail node in the worst case. So both of them should take O of n time complexity. And aside from that, I do nothing, which is non-constant. So the time complexity should be O of n. And for the space complexity, I don't use anything but the pointer. Yeah, so it should be the constant O of 1. Okay, so that being said, I will quickly summarize my today's practice and call it a day. So in this video, I solved the question, remove nth node from n2 list. So I'm giving the head of the linked list, and I had to remove the nth node from the end, from the tail. Yeah, and return the head. Okay, so I introduced two approaches. The first approach is find the length of the linked list and then calculate the index of the node I will be removing from the head, not from the tail. Then I remove that node and I return the head of the new linked list, or I should say, updated linked list. And the second approach was that I used 2 pointers, fast pointer and slow pointer. And firstly, I move the fast pointer by n steps. And then I move fast pointer and slow pointer in the same speed until fast pointer reaches the tail. And at that moment, now slow pointer is slow pointer dot next is the node I have to remove. So I will remove it and then return the head of the updated linked list. Okay, and in either approach, yeah, I had to take care that if n is exactly the length of the linked list, I cannot return the original head, but the second node from the head originally. So that's why I had to take care. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.